options, mainly you have to find out whether these are correct or not. So let me start with first one, which like if a t periodic function fx is integrable on any interval of length t, then can we say that this is true? Okay, so for that, what is a t integrable function? Sorry, t periodic function. Means period is t. Okay, so a function, if you add t, this will be again fx. I mean, like you have, let's say it is a point 0 and it's a point t. At point 0, whatever value, let's say fx, sorry, f0 is this, then at t also it will be ft. So these two values are same. Okay, so if you see this f of x plus t plus t, if you write this like this, then f of this is x plus t will be some x prime, some real number, plus t, which will be, because t is f is t periodic function, it will be f of x prime, and that is equal to f of x plus t. And again, using the periodicity, you can say that this is equal to fx. So that implies what you get, f of x plus 2t also f of x. So, and you will see any f of x plus nt, where n is a natural number, any natural number, for that it will be also this f of x plus nt. So this is one easy observation that is I'm telling. And then, so an integration also. So this is for just addition type of things. This is one property. When you have a function which is periodic, then you will have this type of relation, and you will see that's why sine at 0 it is 0, at pi it is 0, at n pi it is 0. So that is the reason behind sine being periodic function. Okay, so so one more thing, what you can see, it's a periodic, sine function is periodic, right? So sorry, the sine is at 0 0 and it is keep on going like this. So take this 0 to this t, some t interval. Okay, so this, in this interval, whatever the area of this region under this curve, this t to 2t, if you take that region, also will have same surface area, same area. So what it is telling there, because, so let's say if f is a t periodic function, f is t periodic means f of x plus t will be f of x, right? Now what we are saying, this 0 to t f of x dx, and 0 to, instead of 0 to t, if you take t to 2t, or I mean, uh, here it is given also 5 to 5 plus t, like that. I mean, any number, so any 5, let's say 5 to 5 plus t f of x dx. So what is this? So if you assume x plus 5 equal to, let's say x plus 5 equal to y, right? Sorry, not x plus 5, let's say x minus 5 is equal to y, right? You make change this variable, then what you will see, the limit here, x is equal to 5, then y is equal to 0, and x equal to 5 plus t, then y will be t, right? X equal to 5 plus t, then x minus 5 will be t, so it should be from 0 to t. Then if you substitute the value here, it will be y plus 5, and dx will change to dy, right? So if you make change this, then what you get, 0 to t f y plus 5 dy. Now the interesting thing is f of y plus 5, f is a t periodic function, so f of y plus 5 will be f of y, right? Because it is t periodic function, right? What you will getting, 5 to 5 plus t, from 5 to 5 plus t, the lane, the area of the curve fx is, because this is nothing but 0 to t fx dx, right? So y is dummy variable, so we can choose whatever we want. But the thing what we are getting is 5 to 5 plus t, that in that interval, whatever the area, in 0 to t also we have same area for the function fx. Okay, so that is the first question. And you see, while doing this exercise we solve this one. So instead of 5 to 5 plus t, it takes n to n plus t also. So in that case also it will be okay, right? So it does not matter from where to where you are integrating, but you have to integrate on the interval of length t, that type of length t type of interval, 0 to t, or the translation of that. Mainly this 5 to 5 plus t you are translating by 5. So translation won't change the integration value because it is periodic function. But if you take some other type of function, it will change, right? I mean, you take like this type of function, whatever the, let's say t, it is t, but whatever the area here, you don't have the same area here, right? It's not, it is the property of the periodic function, the periodicity gives you this. And you can show that then it is not true, because unless t is equal to 0, it is not true. Okay, I mean, this is not even true for anything. I mean, just 0 to 5 fx dx, it is not true. You can take one in example. Okay, okay, so now the question is, what was the incorrect thing in the first option? What was the mistake? So the mistake was, is it, if it is not given t periodic, if it's not given t periodic, then you cannot prove that this is true. So the only thing has to happen, that has to be there, is t periodicity. Otherwise, you can take one heaviside type of function, uh, which you can then contradict that this first statement is not true. Okay, uh, okay, so that is fine. Then we'll go to this c, the option c and d. I think option c and d I have done already. I have shown that f of x plus any nt will be equal to x fx. So if t is a periodic, then 15t, any nt will be also periodic. Instead of 15, take any nt. N belongs to natural number. Okay, so that will be also true, right? So c is then correct. So a and c both are correct. Okay, so but yeah, d is not correct, because any nt will period, one period of f. Okay, so thus a and c are correct, assuming t periodicity, which you might not see in your uh, assignment. If you don't see, uh, you check it with the instructor and all. Okay, so if is, I hope it is okay, then I will move to the next one. So I have given the solution, so but you have to assume this. Assume periodicity of the function. Okay, okay. So yeah, nt is variant is natural number, is also period of c. Sometime in some book they will define the period of a function by writing the this as this least positive integer which satisfy this f of x plus t is equal to fx. Yeah, I mean that is not some, but it is the definition of period is this: t is the period such that f of x plus t equal to f of x for all x, and t has to be smallest one. But what we have seen, x plus nt also will be equal to fx. In that sense, we say NT also. It is also anti-periodic. T periodic means it is anti-periodic. But the smallest number which is that is the T is that is a period of f. Okay. Okay, so I moved already to the next question, which is uh, regarding the integration of this special type of integration. Mainly we use in used to like evaluate the integration of two function, or let as a vector, two vectors, like dot product of two vectors, or like integration of two vectors. I mean the dot product sometime it like dot product is from space to real numbers, right? So then you give a map and write like this minus pi to pi. So take cos 3x and cos 5x, that component, and make a relation to integration, and that integration by minus pi to pi cos 3x by pi x. Or I mean in the sense of that it's a this is a inner product. Okay, inner product of fg given by minus pi to pi, let's say fg dx, right? So what is the when fg will be orthogonal, I mean when it will be there perpendicular. When you are in Rn, you know how exactly, right? If their dot products are their dot products is zero, then they are like they're orthogonal to each other, right? So here also in the dot product will be generalized to something called inner product, and there if it is zero, then also we'll say orthogonality is something. Okay, there is orthonormality. So all those things, to know about all those things also, you need to know this uh, integration values. So mainly they will be, sometime it is 1, sometime it is 0. So when 1 it is orthonormal, when 0 with all other it will be orthogonal. Those type of things will are there. So that's why these are important. So because you need to know about the basis function of some space, right? Once you know the basis function, you know the whole space. So that reason, uh, you need to know a value of this function, so the product of these functions mainly. Okay, so let's see. So mainly there are orthogonality properties. Okay, which says that minus pi to pi cos mx cos nx dx, that will be 0 if m not equal to n, otherwise it will be pi. See, what it is giving you, 1 over pi, 1 minute. Okay, so 1 over pi minus pi to pi cos mx sin cos nx dx equal to 0 or 1 if m not equal to n, m equal to n. And this set of products, this set of functions cos mx, m belongs to natural number, they become a basis function. Okay, so because uh, or 1 by root pi of that, like you take like that choice, so that becomes some product of this also. You can take mainly cos mx, it's okay. So cos mx will be like ortho normal vector set of, sorry, of basis vector, basis set of basis vectors. Okay, so they mainly they can give you the whole space. Mainly the cos mx function, set of all cos mx type of function will give you the whole space. Okay. Okay, so this is one of the uh, this is one of the formula you have to remember. Otherwise, okay, it is otherwise also you can, in this case you can do also using, see, minus pi to pi. What is the minus pi to pi cos uh, 3x and cos 5x, right? Cos 3x cos 5x. So what is the formula for this one? You know, some formula is there, right? So it will be something called like sine a plus b, sine a minus b. All those things are there, right? Using all those things, or cos a plus b, cos a minus b. Using all those things also, you can evaluate this one. Most probably the sine of a minus b, sine a, sine b, minus cos a, cos b, all those things are there. All those rules are there. Using those, you can also evaluate this one. So this type of formula also we will see in the next few questions. So, but in for this one, you just remember this minus pi to pi cos mx cos nx will be 0 or pi depending on the value of mn. See here you have mn values are different. M not equal to n, so it will be 0. So first one is correct. So what about second one is also m not equal to n, but it's given pi, so it's not correct, right? Yeah, but the thing is, one thing you have to remember is it's asking which one is incorrect, right? So if it's asking, if it's asking which one is incorrect, then what you have to do? So you have to mainly whichever you are correct, you have to guess, telling you whichever is correct, actual correct, that you have to make cross. So this one is incorrect. And then what about these two? These two also, it will be also same. So minus L to L, you just can show it using this some uh, translation. You can show that this is also minus L to L, sorry, hello, mx m pi x over L times cos n pi x over L dx, that is also 0 or uh, L depending on m values, m not equal to n otherwise. Okay, so it's okay, right? Correct, right? So you understand this one. So then what about D? So option D will be, so for option D, this formula is m equal to n, right? Not this formula there. So for cos it will be 0 or, yeah, because this is true for also cos, sine cos also cos, and both cos n pi x over L. So sorry, there is like I'll just show you here. So this sine and cos, they will be always 0. So this is actually always 0. So I'll show you the formula. Okay, so this formula, just use these three formula to discorrect incorrect discard those things. So first one is okay, what I said, this is correct. Okay, it is correct. So now then you use mainly you use these three. So this sine and cos, this sine and cos will be always 0. So product of sine cos will be always 0. They will be always and cos, both cos n pi x over L, n pi x over L, it's like it will be like same of cos mx cos nx. Can just translate it by pi by L, right? So when you write instead of x will be equal to some sorry, yeah, x will be equal to pi x over L will be equal to y, right? So instead of y, if you write pi x L, x will be Ly by pi. And if you substitute that here, you will get mainly the first one. So first one and third one, they are equivalent, and so that's why you can just from here you can evaluate all those things. And the sign cos when it is coming in the product, it will be 0 always. So using that, what you can say, B, C, D, those are incorrect options. Okay, B, C, and D are incorrect. Okay, is it okay for you? Understand? Otherwise, tell me. Okay. Yes. Okay. If not, I will move. So now let's say you have a function which has discontinuity at x equal to 2 and x equal to 4. Okay. So you have function like this. This is the question 3. You have a function like this: 0 at 2 and at 4 you have discontinuity. I mean, you have to prove that fx is whether it is discontinuous or piecewise is continuous and all these things. So what is the how this function looks like first? So if you can draw a graph, then it is very easy. Okay, so let's say I'm drawing like 2, this is 0, 2, 4 and 6. Okay, so in 0 to 2 it is taking values zeros, right? 0. When it goes to from t to 2 to 4, I mean, let me make it more precise, and to make it more precise, let me draw like this. So then it's not reaching to 2 it is not reaching the value 0 when it is at 2, because at 2 it is 1, right? So it will start from 1, and at 4 it won't reach to 1, so it will be like this open type of bracket, you can say. So it we use as a standard notation, and then again it is 0. But at 6 also it will be 0, so because otherwise it is not defined on the interval 0 to 6 which is closed. Okay, so then what you can see, then once you draw the picture you will see it is discontinuous at 2 and 4, because right limit and left limits are not equal, right? It's very easy to see that. This one you have already done in the class, how to evaluate the limit. If you take limit from this side of 2, it will be 0, and when you come from this side it will be 2, which is equal to f at 2. Sorry, if you approach from this side it will be 1, the limit value will be 1, which is f of 2 will be at 2 it will be also 1, but they are not equal. There is a jump, so it is some type of discontinuity, one-sided continuity, right? Continuous, right? From right side if you approach it is continuous, but from left side is not. So that's why it is not continuous. So at 2 it is not continuous. Similarly, you can see at 4 also it is not continuous. So it is not. So fx is a piecewise continuous function, because at each interval from 0 to 2, or let's say from 2 to 4, it is continuous. If you take the open interval, right? Or not even open interval, from 0 to 2 it is continuous, because you cannot reach from sorry, in 0 to 2 also you have a, when we talk about 0 to 2, I mean, when we talk about piecewise continuity, we will say you have a, let's say 0 to 2, whether at 1 we will take the open interval, we will say that in 0 to 1 whether it is continuous or not. We don't worry about the other points. Okay, so that's why this is fx is piecewise continuous function on 0 to 6, okay? In each interval, 0 to 2 open interval, 2 to 4 in open interval, 4 to 6 open interval, they are continuous. It is continuous, not they are continuous. Fx is continuous, right? So fx is piecewise continuous. It is not like there is not piecewise continuous. Piecewise continuous function means some like few, you are taking few continuous function and you are just putting in the each intervals. Okay, so it is discontinuous at x equal to 4, not only at x equal to 4, it is discontinuous at x equal to 2 also. So this a and c are not correct, so fx b and d will be correct. Okay, okay, so these discontinuities are like because of jump mainly they have we have discontinuity, but their one-sided limit will be equal. So it's a right continuity, left continuity. You can talk about those, but you cannot talk about actual continuity. Okay, so that's all for this question. I hope you all understand. So yeah, this answer is also written here. Not, oops. So I'll move to the fourth question. I'll move to the fourth question. So where f1, f2 two piecewise continuous functions, then the product will also be piecewise continuous function. Okay. So and f1 minus whether sorry is a question. So if f1, f2 are piecewise continuous function, can you show that this for whether they are correct or not? What about f1, f2 if they f and f1 and f2 are piecewise continuous? Can you show that the dot product of those two functions will be also piecewise continuous? So we will understand this one with an easy, most probably it will be easy to look at. Let's say you have interval from a to b and the function f1 is discontinuous at c, but this piece is continuous. Mean from a to c it will be continuous and a to b also it will be continuous. Discontinuity is at c. Okay, so it is discontinuity. Okay, f2, let's say from a to b, I have taken a to b, let's say, and we have a discontinuity of f2 at d, right? So and d and c and d are not same point. Okay, so let's say d will be somewhere, it will not either in a to c or from c to b. I have taken from c to b, let's say from c to b. So then if you take the product, let's talk about the product in a to c first of all. Okay, in a to c both are continuous function, right? Because piecewise continuity implies continuity in each interval that of consideration. So a to c it will be continuous. That is not a problem because both are continuous. Let's say c to d, I'll not take from c to b because in c to b the product may or may not be continuous because d the discontinuity point is lies inside the c to b. I'll take c to d where both are continuous function, right? When both are continuous function in c to d, this f1 into f2 they will be also continuous. And now if you take d to b, again you get continuity. So if you have continuous piecewise continuous function, two piecewise continuous function, if you take product they will be also piecewise continuous, but that piecewise continuity may, like the number of discontinuity may increase, right? Number of discontinuity may increase, but they will still be piecewise continuous function. So you have to use here continuity imply the two function you have continuity of two functions, then the product and sum they both will be continuous. Okay, and f1 over f2, it does not first of all make sense of writing f1 over f2 unless you assume f2 is not equal to 0 in whole domain. Okay, right, that is the first thing. So that's why I just remove this one, so you cannot talk about f1 over f2. So a and b they're correct. Okay, so I have given also solution, you can check it. Okay, you have any doubt up to this, you tell me. Okay, any question or doubt?
No, sir. No, sir.
Okay, okay, okay. So now because I'm asking because like I'll be moving to the next part of the lecture, like this tutorial session. It will be about Fourier series on all, mainly your Fourier series and other things. I will see if the time permits. I will write. So the Fourier series of a function given by this. So this is the general notation for the Fourier series expansion of a function. Okay, if you have any function, like if you have a function, you can write the Fourier series. The question is if the Fourier series of this function, particular this function, 1 over 4 pi minus x whole square, right? If that is the Fourier series of that function is given by this, then the value of a naught. What is the value of a naught? How to determine? Do you know anything? What is a
The
naught here?
integral
What is a naught?
one
Right?
1/2 pi.
Sorry,
That Fourier form, the first variable of the Fourier
but you
expression.
have you have a naught by 2, right? Did you see
Yes,
that?
yes.
So then a naught will be 1 over pi. Is it correct? Whatever I have written in this case. Let's talk about let's say in this case. Is it correct?
Yeah. So normally
Yeah,
a naught is equal to 1/2
exactly. So but here it is a
pi.
naught by 2. You are correct. You are correct. I'm not telling you are not correct, but I mean that is mistake is a naught by 2. It is given. It is here. Here it is given a naught by 2. So instead of when you take a naught over 2, this term actually this term is equal to 1 over 2 pi minus pi to pi fx dx. When you take a naught over 2, it will be 1 over pi, right?
Okay, that 2 cancels out.
Exactly. That 2 will cancel out, right? A naught over 2 is equal to 1 over 2 pi minus pi to pi fx dx. So you take when a naught, then a naught will be 2 will get cancelled in both sides, then it will be 1 over pi minus pi to pi fx dx, right? Yes.
Okay, sir.
Yeah. So then, so once you know all these things, you can just evaluate 1 over pi, then minus pi to pi in this case, 1 over 4 pi minus x whole square dx. So that will be 1 over 4 pi minus x whole cube over 3 minus pi to pi, right? At pi it will be 0 when it evaluate, and then at minus pi it will be 2 pi cube. So 8 pi cube over 4 pi times 3. Why I'm writing this 4 times 2, it will be 8. So 2 pi square over 3, right? A naught will be 2 pi square over 3. So what is the value of a naught? A naught is 2 pi square over 3. So yes. So here also most probably the best options would have been pi square over 3 also, because the mistake mostly people will do is 1 over 2 they won't multiply, right? So that will make more make confusion. Okay. Usually people does in like people set questions in competitive exams like this. So to 5, so 1 over 2 mainly you will forget, and that solution also will be there in the option. Okay. Anyway, that is a different matter, but the thing is option B is correct. Okay. Is it okay? Just
Yes, sir. Yes, sir.
we use formula. Okay. Now it's a more thing you need to find whether what is the values of a1 and b1. So let me write it first. So what are the values of a1, then we'll find what you have to do, right? So instead of a1, let me write it, I mean, an. Okay. What's the value for an? for this type of series? What's the value for an? Yes.
Sir, 1 over pi. Hello.
Okay. Then
1 over
yes, yeah.
pi
0 to 2
integral
pi. Then
0 to 2 pi, and then fx
whatever the
dx.
integration,
fx
not effectively. A,
cox cos n
see this cosine x,
cos
not sine,
nx
right?
cos
Exactly.
nx.
Exactly. So once you know this, then you are done. Nothing is there here. So 1 over pi, 0 to 2 pi, right? Fx sine nx dx. So here in what you need to find a1, which will be 1 over pi 0 to 2 pi fx cos x dx, right? So once you have this 1 over pi 0 to 2 pi, what is cos? What is fx here? Fx will be sine x in the interval 0 to pi. Otherwise, it is 0, right? So so the integration I will make from, instead of 0 to 2 pi, I'll take 0 to pi and pi to 2 pi, right? 0 to 2 pi, then what is the value of fx? That is sine x cos x dx, right? Plus 1 by pi integration 0 to pi 0 times cos x dx, right? Because the in the interval, sorry, not 0 to pi, the next one, it is pi to 2 pi, right? Pi to 2 pi. Now I evaluate, it will be 1 over pi 0 to pi. What is the this one? Sin x cos x dx. How do you evaluate this? One easy thing will be just uh, take this as 2 pi times 2 sin x cos x dx is equal to 1 over 2 pi 0 to pi sin 2x dx, and 1 over 2 pi, it will be negative of cos 2x, right? No, it's positive of cos 2x. Why positive? It's a negative, yes. Negative of cos 2x over 2, 0 to 5, whatever the integration, right? Because the integration of minus cos is sine, right? Sorry, derivative of minus cos is sine, so the integration value of minus cos x will be uh, minus cos 2x, but 2 will be the value of integration of sine 2x will be cos minus cos 2x over 2, and when you evaluate from 0 to 5, what will be that? 1 over 2 pi. So minus cos 2 pi over 2 minus, so minus or minus plus cos 0 over 2. Cos 0 is 1, cos 2 pi is minus 1, but minus 1 again you have minus 1, right? So it will be half plus half, it will be
0, sir.
1. No, it is 1, right?
Half minus half.
So cos 2 pi is minus 1, must or okay, 1. Yeah, it is minus 1. Yeah, so it's 1, so it is okay. Yeah, I understand. So 2 pi 0 minus 1 minus 1 minus 1 plus 1, right? Cos 0 1 minus half plus half, that will be 0, right? So yeah, a1 will be 0 then. Yeah, a1 is 0. A1 is 0. First one is correct, but it is written that a1 is equal to 1, so this is not correct. So not, now you have to evaluate what is b1. Similarly, if you evaluate b1, v1 will be 1 over pi fx, 1 over pi fx, of course 0 to 2 pi cos x, because not cos x, sin x, sin 1x, so sin x dx here, right? So when you put value, it will be only from 0 to pi, the value will be there. Otherwise the value will be 0, so I won't write that. So sin x square x dx. How do you evaluate this? Again we do this 0 to pi 2 sin square x. What is the value for 2 sin square x? 1 minus, I think 1 minus cos 2x, right? Cos square minus sin square x. Cos 2x, cos square x minus sin square x. 1 minus cos square x will be sin square x. Another sin square x will come into the picture, and that will make you 2 sin square x. Okay. 1 over 2 pi, then x minus sine 2x over 2, 0 to pi, and this quantity will be 0 for both 0 and pi. This one x will give you pi minus 0, which is 2 pi. 1 over 2 pi, pi minus 0 will be 1 over 2. So v1 will be 2. So a and d options a and d are correct, b and c are not correct. Okay, so this is how you have to evaluate. This is easy, very easy. Once you know the, once you remember the formula, just it is very quickly you can evaluate. Okay, let's do this one now. So what happens when x tends to 0? It is continuous, right? So continuity is not a problem. So the function is, so function will be continuous, but whatever f prime x, if you take limit as x tends to 0 plus, right, fx, what will be that? That is limit x tends to 0 plus 2 minus sine inverse x. But 2 will be 2, it will remain same, and sine inverse x, which is continuous function, which is 0 when x approaches to 0, so this will be 2. Similarly you can show that limit x tends to 0 minus, similarly limit x tends to
So both
2.
sides 2 आ जाएगा sir.
Yes, so both side
Both
when it
sides.
comes to, can you say that it is continuous then? Not, right? But
Yes, sir.
it
LHT
is,
equal left hand side equal to RHS.
but f2 also has to be, sorry, not f2, f0, what I'm writing. So f0 also has to be 2, right? But it is coming 2, so that's why it is continuous. Only left and right hand limits are equal, then it won't be continuous, right? The continuity definition will be complete only when you have both left and right limits are equal and they are equal with their function value at that point, right? So anyway, all these things are here. The function is okay for the function is completing all those properties, so the fx will be continuous, 1 minus 1 to 1, right? So but what about f prime x? So b, option b is correct, option d is not correct. That's all we know, but we got till now. But what about f prime x when
Sir,
it tends to
RHD
0?
LHD
Sorry,
RHD LHD check RHD and LHD check.
what is RHD?
Right hand differentiability and left hand differentiability.
Yeah, that's what you have to do, right? First of all, whether left and right limits are equal or not, right? How do you do that anyway? F prime x will be appro, so what, first of all, left and right limit, so limit h tends to 0 plus f of x plus h. In this case, what is x? 0, right? I mean 0 plus x is also 0, means 0 plus h minus f of 0. Are you talking about this one? over h, and also we'll evaluate h tends to 0 minus. Are you talking about this? If not,
Yes,
say.
sir. Yes, sir. Yes, sir.
Okay, so then limit as h tends to 0 plus, what is f of 0 plus h? 0 plus h will be in this interval 0 to 1, so 2 minus sine inverse x. 2 minus sine inverse, here it is h, sine inverse h, minus what is f of 0? F of 0 will be 2 over h, right? So that gives limit h tends to 0 plus, so negative I will take out, and then sine inverse h over h. Okay, what is this 0 by 0 form, right? Sine inverse h approaches to 0 as h tends to 0, so it is 0 by 0 form. So you can take, I think, integration, sorry,
L'Hopital,
differentiation
sir.
on both
L'Hopital.
L'Hopital, yes. So 1 over what is sine inverse x, this integration, what is this value? This will be 1. What about this? What about ddx of sine inverse x? Square root of 1 minus x square, is it? I forgot. Say, let's. I'm just guessing it. What will be the integration? Sorry, differentiation of this sine inverse x?
Yes, sir. Same, sir.
Same now. It's
Yes, sir.
okay.
Yes, sir.
Okay. Then I will not check anywhere. So it is 1 minus h square, and now you have minus of limit as h tends to 0 plus 1 over square root of 1 minus h square, which will be equal to minus of 1 over square root of 1 minus 0, which is minus 1, right? Right, am I correct? So then I'll use some different color. So limit now h tends to 0 minus the same uh, fraction, the same fraction I will take for 0 minus. So f of 0 plus h minus f of 0 over h, right? It's correct, right? Yeah. So limit h tends to 0 minus f of what is f of 0 plus h. So h tends to 0 minus, so 0 plus h will be in 2 plus sine in 2 plus sine inverse h, right? And f of 0 is 2, so it will be this over this, and then you will see it will be 1 because the negative sign before sine inverse function is not available now. So it is due to the fact that you are taking limit from left hand side, right? So anyway, like the right limit and left limit, when you approach from both sides, they are different, and what we say, it is not differentiable at that point 0. Okay, yeah, there is a answer also given. Okay, is it anyway, is this okay for you? Can follow
Yes, sir.
this?
LSD not equal to RSD.
Exactly, you were correct. So LHD not equal to RHD, so this is correct, this is not correct. So limit as x tends to 0, f prime x does not exist mainly. Okay, that's all we can say. I mean, f is not differentiable at 0, right? It's not differentiable at 0. That also we can say. So what about question 8? So again, Fourier series came into the picture. At x equal to 1, the Fourier series of f will converge to minus pi 0 to pi of I.
So Fourier formula expansion for x minus 1
Why not 2 pi?
and 2 pi also.
Yeah, I mean whole thing you have to do, right?
Yes, sir. Both.
Okay, you do and let me know what is your answer. Okay.
Okay, sir. Okay, I will try, sir.
Yeah, you try for some time. Yes. I just thinking about this. So you just take a note for this function maybe, and x at x equal to 1 where the function will converge. Okay, not just the series you just find. So the where does that series converge? So convergent of series it is talking about. Okay, remember that. Okay, so you do this one. I'll mainly here. I'll this option. I will make it more correct. This is f is instead of this limit extends to 0 f prime x, this makes different meaning. So f is differentiable at 0, I would say that, and this one instead of that f is not differentiable at 0, because what I was thinking, because f prime x limit extends to 0, that is mainly you are talking about the function f prime x as extends to 0 whether limit exists, and that is you are talking about the continuity of the function f prime x, whether that is equal to 0, whether that exists or not. Okay, so instead of that I think it is better to deal with the function whether it is differentiable or not first of all at that point. Okay, if it is even not differentiable, then you cannot talk about f prime x. So in here what you see f prime x at 0, you cannot talk about that, right? So limit extends to 0 of f prime x, even that also you cannot talk about. So better to first of all deal with whether it is differentiable, then you talk about f prime x. Limit of x tends to 0 f prime x, whether that exists or not. Okay, this one whatever the first the f prime limit extends to f prime x doesn't know, that is also okay kind of, but better to write it like f is differentiable at a 0 or not. Anyway, the solution will be same for both two, but it may confuse you to deal with this. Okay, first of all f prime x, it does not exist even, right, at 0. So how do you talk about limit extends to f prime x? Maybe limit extends to f prime x, you can talk about that. If it's not 0, at 0 it is not defined, but it is defined in the open interval 0 to so minus 1 and 0 to 1. If there it is, then it is okay. So there also it will be okay. So it will be 1 over square root of 1 minus x square and negative 1 over square root of 1 minus x square. In that, then if you take limit as x tends to 0, then the option I started with, that will be also then correct. Okay, minus 1 and 1 limit x tends to 0 f prime x, you can do in that way also. Otherwise you can think about in differentiability way. F prime even does not exist at the point, but limit extends to 0 and f prime x, that you can talk about in the interval minus 1 to 0. There you can talk about extends to 0 minus, and 0 to 1 extends to, that will be extends to 0 plus, and all on those intervals they are smooth and the f prime exist, right? F prime, they are these are f prime values, f prime, right? So limit extends to 0, then you can talk about, and you can again similarly show that it is they are minus 1 and 1. So it's not if limit extended to f prime x does not exist. Okay, that was a small correction I wanted to make. And then here's the eighth question. So instead of finding this the Fourier series of this function, so much easier way is there, which says that Fourier series will converge to. So yeah, mainly you need to find at x equal to 1 where does f will go. If that is f of 1, you do not know f of 1, right? F of, I mean, where the Fourier series of f will converge, that will converge to f1 minus plus f of 1 plus over 2. So that's a formula. And then f of 1 minus, what is f of 1 minus? 1 minus here, so it will be 2 pi. 1 plus here, but it is x minus 1. So at 1 it will be 0. So 2 pi 1. So Fourier series of the function will converge to pi mainly at x equal to 1. But where does the function value you see f of 1 is 0. Right? So but Fourier series will mainly converge to the average of first, I mean average of right limit and left limit, and then you divide by 2.
Okay, sir. Okay. Yeah, this is a new way. I thought that is a long process. If we are
Yeah, it will be
expanding.
long process. I think it is there. If it's not available, then like I'll see how to get this formula first of all. Okay, this one I may make a video maybe on this, but I right now I can't remember how to obtain this one from the usual Fourier series expansion. Okay, so because function, this will be a naught plus summation over a n sin n x, right, plus b n cos n x, right, that type of function, that type of thing. And then mainly f of 1 you need to, f of 1 will be a naught plus this series, and this series where does this converge, so that is given by this will converge to f of 1 minus plus f of 1 plus over 2. It is telling using Fourier series expansion, so that we need to check it, like we need to prove it. But this is, you can check any textbook of Fourier series, mostly it will be there. If not, I will tell you, okay, in the next class. But the thing is, Fourier series will converge to pi here. It's not to 0, which is the function value, okay, that is to remember. So remember, this is a discontinuous function, so it might not behave well for Fourier series. So that's why the dilemma you can see. because f of one value 0 and the Fourier series is converging to a different point, all those things. Okay. So now let's talk about this function x cube minus pi square x. Where does this converge? So whether this converges uniformly to f 1 minus pi to pi interval. Okay. Whether it's correct, like true or false. So remember, this is a polynomial function, right? Don't get afraid by saying minus pi square. It's a coefficient of that function. Otherwise, it is coefficient of x minus pi is pi minus pi square. But otherwise, it's very nice function x cube minus pi square x. That's a hint. So when you have a function which is polynomial, so that implies it is a continuous function. Okay, continuous 1 minus pi to pi, even it is differentiable function. Okay, but can you say for all differentiable function the Fourier series converges uniformly? Not, right? Not necessarily. So here you need more condition to converge uniformly. Okay, what is that? So first of all, a function f is continuous and differentiable. Then you have to have the differentiable. This f prime is at least piecewise continuous. Then yeah, one more thing. So something boundary condition also wanted to put. What is that? So f of minus pi uh, equal to, also you have seen f of minus pi equal to pi equal to 0. So then, so f is not f is the Fourier series of f will converge to f. This was known to you, or this was known or not?
So
So this is a
continuity,
uniform. Yes, yes,
continuity and
tell.
differentiability is clearly seen, sir.
Yes,
And then piecewise continuous, that that we have to find out.
but what is f prime?
F prime.
What is f prime of x? That is 3x square minus pi square, right?
Yes, sir.
It's very easily piecewise continuous function. I mean, it is continuous function, right? The continuous functions are piecewise continuous. What is the problem? But piecewise continuity does not imply continuity. But continuity implies piecewise continuity. What is the problem? There's not a one problem.
So these three conditions are basic conditions, sir.
No, there the function is satisfying these conditions also. Okay.
So that's why it is converging, sir.
Yeah, it should. It will like uniformly converge. Okay.
Okay, sir. Okay.
Okay, so that was the thing. I mean, the boundary condition also has to be this is boundary associated boundary condition. Boundary condition mean the minus f of minus pi at f of minus pi and f of pi, they have same values, and if you take the Fourier series value and Fourier value of this f of minus pi plus and f of minus pi minus over 2. Okay, so what will be that? So f of minus pi plus f of minus pi plus will be, so it will be same, both are a minus pi or plus pi. For both that thing it will be same type of, and that will be minus pi cube and minus pi cube plus pi cube, right? And again that it will repeat minus it is pi cube minus pi cube. It will be by 2, it will be 0. I mean that same 0 value in the on the boundary, the this Fourier series of function f, Fourier series of function will converge to a that point at pi, it will converge to 0, and the value of f of pi it is 0. Also f of minus pi, at minus pi it will also converge to 0, the Fourier series, and that's it will be also f of minus pi also it is 0. So that condition also should not disqualify. I mean it should attend that thing. Okay, so I may give you uh, one exercise like where you will see the due to the boundary condition, it won't be convergent. Okay, anyone wants to say something? So let's say I have taken fx equal to 1. Anyway, so this question is done, so it is, we can show that it is uniformly convergent. Okay, let's say fx equal to 1. What will be the Fourier series for this fx equal to 1? Can anyone tell me quickly? Fx equal to 1, what will be the Fourier series of this? It is 1 for all x. Okay, what is the Fourier series for this? So here you will see if the sine series, the Fourier series. So the sine Fourier series will be looking like n is odd 4 by n pi. You try to find it. You assign nx, okay. And 1 is very nice function. It is it is differentiable function, and every time differentiable. And so f prime will be piecewise continuous, but for this point the Dirichlet boundary condition is not satisfying. So this condition at minus pi it is 0, so that condition is not satisfying. So associated boundary condition won't satisfy, so that's why it won't be piecewise it won't be uniformly convergent. Okay, it is piecewise convergent function. When the Fourier series will converge for each x. If you fix x, so this series will always converge to 1 for all x. But you have to fix x, and for those each fixed x it will converge to 1. But if you just varying x, and for all x that uniform convergent, if you want to talk about that, then it won't be converging to 1 uniformly. Okay, but for each x, that's the point here. So when we talk about uniformly convergent of a series of functions f and x, so f and x converge to fx, we not denote like
Sir,
this fn.
sir, this
Yes.
this summation will be having 1 plus this sin x, sin nx.
1
1,
plus n is odd
1,
mean yes.
this is the Fourier expansion, na sir?
Yeah, sine Fourier sine expansion, yes.
Sir, a naught will not be 1, sir.
A naught.
Yes, sir.
So what was a naught formula? You 1 over 2 pi. What was this? So which question you are doing? Yeah, so 1 over 2 pi.
That fx equal to 1 you asked for.
Yeah, fx equal to 1, and the sorry the interval also I will say. Interval you can take minus pi to, so 0 to pi, let's say you take 0 to pi. 1 dx. I mean, yeah, 1 by pi, 0 to pi, 1 dx, right? Fx dx it was, right? So
Sir,
n is odd mean.
why not 0 to 2 pi, sir?
Sorry?
0 to 2 pi, 0 to
Yeah, yeah,
pi.
0 to 2 pi you take, no problem. 0 to pi or 0 to 2 pi, I think no, will not make any problem.
Okay, it will come out x then.
Yeah, I mean 2 pi will come out, right?
Yes,
X
sir.
will be 2 pi, means some a naught will be there. That's what you were telling.
Yes, sir.
I mean, I think n is odd and then some n equal to 0 or something. Okay, no. Then 1 plus also should be there. Okay, it might be okay if it's there. So let's just add it. But other things are okay.
Yes, sir. Mainly we are concerned with sin and x.
Exactly. So sin nx, and then what I'm talking that this one fnx is converts to fx point wise if that is happening for fnx naught tends to f of x naught for all x naught fixed x naught which are from the wherever from x are. But when you take a uniform convergent, this we not like this, and fnx fx we don't talk about x precisely. X when we talk about convergent, that convergence will not depend on x that time. Okay, so for any x what you give, it will not depend, the convergence it will not depend on x. But here convergent may depend on x. So uniform convergent and this pointwise convergence, they are little different, and in this case that's why the things will be, I mean, the series will converge to one point wise. So you fix any x and then it will converge to 1, but as a whole, like, you don't fix x, just want to make sure that it converges with respect to any x you want. When the convergence does not depends on x, that type of convergence if you want, then it won't be converged. It won't be that uniform convergence you won't get. Okay, so that is okay. I'll just make it precise. 1 over pi, and this is 0 to pi interval you are considering, fx equal to 1. So it won't be uniform conversion due to this boundary condition, that boundary condition is not finishing at 1, so it won't be uniformly convergent. Okay. Any concern here? So this mainly, this has to happen. These three conditions, they are important for uniform convergence. Okay. So there may be other way to show that one function, the Fourier transformation of a function, converges uniformly, but this is one of them, where it shows that if it has to be continuous and differentiable, f prime has to be piecewise continuous, and the Dirichlet bound type of boundary condition should be also there. Then it will be the Fourier series of the function will converge uniformly to f. Okay. Any other theorems you know which says this?
Hello,
Sorry.
hello.
Yes.
It is going on, sir. We have to submit assignment also. Okay, this is still going on. Week 7 is going on, sir.
Yeah, week 7. It was supposed to be, this class was supposed to be on Sunday, right? Yeah, I mean, this type of question, you got the assignment? Hello? You got the assignment already? I can't
We,
hear you,
we
any,
will
right?
we have to submit till Wednesday, sir.
Yeah, but what are the questions in the assignment? All these are included in the question?
Yes, sir. Same, sir. Same.
Oh,
Not the numbers, but pattern is the same, sir.
oh, okay, okay, okay. Then it is good for you, right? You can do same type of things. If you just do a class here, you can just then try there. So many in the solution of question 9, many things are not written, but you refer here. So these four things: continuity, differentiability, and piecewise continuity. So then it will be for Fourier series will converse. I think I should make some videos on this Fourier series or some class. If you want, I can make some live class maybe in YouTube to make a like question answer session in question answer session or the on the Fourier series, something about Fourier series and all the first question solving.
Yes, sir.
Then
Yes, sir.
okay, that I may do that. I but I need some time. Oh, I cannot do before your Wednesday. That thing I cannot do. I mean, before Wednesday, doing one class. That is not possible now because I am in some work, so I cannot do now that. So it will be maybe next week, next to next week maybe, or next week. But I can do that if you want, because this will be needed for not only for this. Maybe you, if you are giving exam for this course, then also it will be needed, right? So anyway, that class will be useful. If you want to attend, you can attend. Otherwise, it will be there in YouTube. You can see anytime. But I want to make, because this, I think it is not, some things are not clear, because this uniform continuity and continuity, sorry, uniform convergence and convergence, mainly the convergence of the Fourier series, that might be little bit difficult to you, and how these formulas are coming. If it is very big, I mean the proofs are very long, then I will not do maybe. But otherwise I will try to give you some justification, how the convergence property of this, and how does, like, this type of some other theorems whether are available. So this theorem anyway will give you the guarantee of uniform convergence of the Fourier series expansion. But are there any other choice? Why the, like, this boundary condition is like this Dirichlet boundary condition? Why can't it be something different? So all this thing I can do in that class. So it is not possible in this class now, and not before. I cannot do before Wednesday also. But before Wednesday you can use, I think, these things whatever I have done now to the to submit your assignment. Okay, but for the next, like, last exam, or for your, like, to know better, or if you want to use these things somewhere, then you need to know about Fourier series. Okay, so if you want, I will do that in here, as you, one of them are, you are telling, one of you are telling, so I will do for sure. But I need some time, not in this week. Okay, is it okay? I don't know whether you people are here, so I'll move to the next question, and most probably it will be the last question if you don't have any doubt. Okay, read the question. I will do in some few minutes. Okay. Okay, so there also might be some outside noise which might distract you, but I cannot do anything here. I'm just sitting inside a very closed room also, but still it is coming. So some functions are going on. I mean, the functions is not the same function here we are talking about. Some Fourier series of function, that not that function. I'm talking about some this festival. Some festival is going on, mainly, if I say precisely, which I cannot say anything. So I don't have power to just switch off their mic and do. Okay, so that's why I told I will take one more class where I will teach you about Fourier series little bit, which are important for you. Okay, for now, what you do, you, whatever I did now, I think while teaching, I think not much problem, not much music was there. But when I stop talking, then some music you might hear. So that I cannot do anything. I am still, I'm like in a very closed room. Still, it is coming, so it's very noisy outside. Just if I go outside, then you maybe you can't hear me. But I think it is kind of manageable when I was talking, right? So please try to consider this. So cooperate for this time, okay? Because music I cannot do anything. I just maximum I told that I can take one more class, okay? One more class, not because of this only this music, but few important things about Fourier series and the convergence of the Fourier series, okay? So any other doubt, you turn on your microphone, just unmute yourself and tell me. So that is not a problem, okay? uh, okay, so now let's do this one. Fourier series of fx pi minus x by 2 is a very nice function. So and at 0 it is pi by 2, at 2 pi it is minus pi by 2. So the values are not same and they are not 0. So most probably you cannot talk about, not most probably you cannot talk about uniform convergence, but you can talk about still pointwise convergence, right? So this function is pi minus x over 2 in 0 to 2 pi. This is, at 0 it is pi by 2, it is 2 pi, it is minus pi by 2, and at pi it will be 0, right? Okay, so nice function. So pointwise convergence won't be a problem. Why I'm talking about the pointwise convergence of this function? So see, at some, for some values of x, you can write this series like 1 minus 1 over 3, 1 over 5, minus 1 over 7, 1 over 9, like that. And then you use the where does this converge, and you know the f value, what is the f value, okay? So find out the x value here, and then it will converge to that x plus f of x minus over 2, because its pointwise convergence is there. So there's the hint you would try. Okay, so I don't know whether people are here or not. Anyway, so one note I will give: the pointwise convergence
Sir,
criteria.
I tried, but it is not coming. Pi by 4 is the option, sir.
Sorry,
Is it
pi by
pi
4.
by 4?
Most probably, I'll see. But that is maybe you were saying from just the summation of this, the value of this. You have to evaluate from the series expansion given. Okay, f is
Okay.
continuous and f prime is piecewise continuous. Then Fourier series of Fourier series of f will converge to if pointwise. And I think you know about what is the meaning of being pointwise. I told already. So if that is so, then how this sine nx over n will, which summation? So f is given like this, and what is f? F is pi minus x over 2, pi minus x over 2. So now if you, as n equal to 1 to infinity, right? So if I now see only the terms which are odd, they are there, right? Otherwise the values are like no values are there, right? So if you, what you should take, so that sine nx over n summation will be 1 minus pi by 3 plus pi by 3, like that it will keep on going. See, then f at pi by 2 should be n equal to 1 to infinity sine n pi by 2 over n. Now what is this when n equal to 1? Sine pi by 2 over n, sorry, over 1 plus sine 2 pi by 2 is pi over 2. So because I want the even terms to vanish, so sine pi will be 0, sine 2 pi will be 0, like that it will keep on going by. But what about sine 3 pi by 2 over, it will be 3 plus sine 2 pi over 4, and it will keep on going. And if you see what is sine pi by 2 value from here, sine pi by 2 value will be 1. What is sine 3 pi by 2? This pi plus pi by 2, right? So it will be negative of 1, so negative of 1 by 3. And you will see it will plus positive of 1 plus 5 and negative of 1 over 7, it will keep on going. So that's why this series is this. So but at pi by 2 we know it converges to f of pi by 2. It should converge because it pointwise converge. So if is continuous and f prime is also piecewise continuous in this case. If x is this and f prime x will be minus 1 by 2, which will be constant function, is piecewise continuous. So what will happen is, uh, so this series value will be f of pi by 2, and f of pi by 2 you know from the Fourier, the function value f of pi by 2, pi minus pi by 2 over 2 will be pi by 4. Do you understand this? So how easily we can find out the series value? So knowing a series value is not very easy, right? Series value is a little bit different, because how you do this? What is this 1 minus 3 plus 1 by 5 minus 1 over 7, and it is keep on going. This is this series where it converges. First of all, how do you talk about convergence? First you take 1, you take 1 minus 3, it will be some 2 by 3, right? Some number. Then 1 minus 3 plus 1 over 5, so it will be some 2 by 3 plus 1 over 5. Okay, but again you 1 minus 3, so 1 was bigger, and then it reduces 2 over 3, but again it increases, plus 1 over 5 minus 1 over 7. So whatever that number that is less than this, so it is keep, sometime it is increasing, sometime decreasing, maybe it is by very less number. So it is very difficult to predict about this sequence. Mainly when we talk about the convergence of this series, mainly we talk about the sequence which is like this, which is a point x1, it's x2, x3, x4, and it is keep on going. What is the value of xn as limit x tends to limit n tends to infinity xn? That is nothing but this series value. So it's not easy to find out this series value easily,
Sir,
but here,
sir, hello,
yes, yeah, please,
hello.
yes. Yeah, can you hear me?
Sir, you check that point, that sequence at every Fourier point, at every Fourier.
Will converge.
Yes, sir.
Yes, yes, will converge using this one. If I have a continuous function and the difference, the derivative is also piecewise continuous, then yeah. Any doubt? I can't hear you. Maybe, and maybe I'll check your message. Maybe here.
This series forms Fourier points, sir.
Sorry.
This series repeats, this series is repeating itself at every Fourier point.
No, every Fourier. What do you mean by Fourier point anyway? It's I mean, any point you would take from 0 to 2 pi, will that give you the same thing? No, right? This series is, you can obtain if you take pi by 2, maybe some other value, but not for every value, right? Just take x equal to 0. The series is always 0. Take x equal to 1, it will be a little different, which belongs to 0 to 2 pi. Okay, so to take pi by, take a value in such a way that it should give you the series. The series means series value, like we want to find out the value of this series, right? So that series, how to obtain for a particular value of x only, you are obtaining this, which I showed here. It takes different value, it will convert to different, all these things are okay, but you don't get the series which we want. The series the question is asking. Okay, that's why we have taken this. Yeah, is it okay? No, like what was your concern otherwise?
Hello.
Yes.
Okay, sir. Okay.
Okay. Okay. So if everything is okay, then I think we can finish it off. Okay. Any other doubt?
No, sir. Okay, sir. Okay.
And what about the other class time? Any time you want, like in a week, if you want any, if you have any preference, you can tell me. Okay. Time
Okay, sir.
preference.
Okay, sir. Good night, sir.
Okay. Good night. Okay. Thank you. Thank you all for your attention. Okay.